National Experimental Central Neural System Injury and Repair. So, Uppsala University, Sweden. So,
okay. Do you have a pointer?
we have no.
No pointer? It's okay. Okay. I recommend.
Okay.
Yeah, I recommend. So, last week, learning Russian. Yeah. Well, I'm very grateful to Igor and Paulina. She worked a lot for my coming here, visa and all other things. And I'm greatly honored. We wish to develop some kind of cooperation. So I'm telling my side of the story. And if you have any question, anytime, stop me, because it's not me to listen to all lectures before you ask me questions. Okay? So, okay, I understand.
The first.
The first one.
Yeah.
Oh. Okay. So I'm from Uppsala University. This is founded in 1476, very old university. And this is a large project. This is Department of Defense, United States of America. It is Swedish Strategic Research Foundation. And this is European Office of Aerospace Research and Development. National Center of Toxicological Research here. And US Air Force Research Laboratory, Swedish government. So it's a multilateral project, and we are working since 2003 on. What I'm telling is that this is my personal view, which has nothing to do with any organization I am representing. And I just show you this, that in your life also there are failures, but you should not worry for failures, just work with great enthusiasm. This is Sir Winston Churchill. I talk about nanomedicine, and nanoparticles are everywhere, even in your room, and depending on its exposure and duration, you can be sick, or even if the drugs are delivered using nanoparticles, it can help you. So the point we are asking that what is the need of nanomedicine? It's used for drug delivery, and also this nanoparticles depends on their size and type. They are also modulated by external factors, like if heat is there, cold is there, or even you have traumatic injury, it will affect the changes. When we talk about brain, we talk about blood-brain barrier. And this is Dr. Stanley Rappaport. He is father of blood-brain barrier. He wrote his first book in 1976. And then I did a PhD thesis in India at that time in 1982. And this is my supervisor. We are talking about not only neurons, because neurons, of course, how many neurons in human brain is present? Do you have any idea? Say any figure. Millions, billions?
3 milliards maybe.
10 billions.
10?
This is recently calculated, 10 billions. Okay. And the glial cells are even much more in number, and endothelial cells that constitute the blood-brain barrier is even 15 times. Just a rough calculation. So, we showed in this book in 2003 that blood-brain barrier is very important, and its foreword was written by Milton Brightman, who discovered the anatomy of the barrier, you know. Doesn't move. It's light. It's stuck. Okay. Can you help me? It's stuck. Doesn't move. Now, no, it's going back.
Oh. How it's
Now it works. So this is the two endothelial cells. I was looking here in translucent electron microscope in this institute, and it was great. This is the electron microscope taken in Sweden, and you can see these two clear endothelial cells, and these are the tight junctions. Lanthanum has stopped here. So this is the anatomical site of blood-brain barrier. I am basically a neuropathologist, worked with Professor Ingve Olsson in Sweden since 1988. Actually 1996, this picture was taken in 1988. Also I worked with another great neuropathologist and electron microscopist, Dr. Sarbos Navarro, Professor Dr. Sarbos Navarro. He is one of the living legends in pathology from Europe, and we were working in German government fellowship from Bowl Foundation in Berlin at that time. And this is my wife, you can recognize. So we are talking about all the time this blood-brain barrier, because this can produce edema if it is damaged, many cellular changes and cell death. Oops. I will show you some of the example in Alzheimer's disease, because there is many people are suffering in many parts of the world with this disease. And according to United States 2017, we have more than 5 million Americans, they have this Alzheimer's disease, but Alzheimer is not the property of America only. This is present in all over the world. Since the United States is doing much more care in counting, so they have published this data. And we published this paper in molecular neurobiology that has an impact factor of 6.3 recently in Alzheimer's disease. So this was the first case that a German physician described this disease, and his name was Alzheimer. So on his name, the disease carries his name. In pathology, Alzheimer's brain looks like this, and normal brain is like this. When you cut the sections, you can see this old senile plaques that has been part of Alzheimer's disease, and also this is the amyloid beta peptide. And then it's molecular biology. They can produce cleavage of enzyme, they can produce tau protein, and that disintegrate the microtubules, causing the pathology of the brain. This is just a cartoon showing how this beta amyloid peptide is cleaved and produces different factors that is causing brain injury. I show this cartoon because endothelial cell is very, very important apart from neurons, glial cells and microglia. When I say glial, I largely mean astrocytes, but it also includes microglia in some of the cases. But we have not investigated microglia because we feel that they are the doorkeepers. I mean, anything will happen there today. So, since our focus is on blood-brain barrier, I summarize some data telling that in Alzheimer's disease also blood-brain barrier is broken down. To further prove human brains affected with Alzheimer's disease, we can see vascular changes. So degeneration in 100 places, extravasation of serum protein. You have in your blood albumin, isn't it? Albumin, fibronectin, so many things are there. So they are going to the brain by itself when the barrier is open. And you can look immunohistochemistry, you can find fibronectin, IgG and albumin, so you can see that blood-brain barrier is broken down. You don't need any external process. And also you know that blood-brain barrier is controlled by enzymes. These endothelial cells are not sitting idle, they have physicochemical properties. So these enzymes that represent the blood-brain barrier also altered in Alzheimer's disease. Physiological changes in Alzheimer's disease, these are the cases. You can understand that, and many authors have reported. So the question is, Alzheimer does not only mean amyloid beta peptide, it has many different things. So some people have started thinking about neurotrophic factors, because neurotrophic factors are helping in brain regeneration. Okay, so these are some of the examples. In 2011, people are talking about nanomedicine in Alzheimer's disease, because they want to deliver the drug much efficiently for longer time, okay, and faster distribution in the whole brain. So that's why nano delivery is used. So people are talking since 2011. We are working on a drug called cerebrolizin, and I think it is deep rooted in Russia. People have used long ago, And at the moment, this drug is manufactured by an Austrian company called Pharma, and this is a mixture of different neurotrophic factors. I know some of my friends who are in NIH now from Russia. They told me that they also received a treatment for themselves when they were in Russia. So I mean, this was a Russian drug, I can say. So this neurotrophic factor combination is now manufactured in Austria. We have used it and tested in some animal models like traumatic brain injury because it is neuroprotective, enhanced neurodegeneration and synaptic plasticity. Okay? So this is a wonderful drug in our hands, at least in animal models. So then we did albumin immunohistochemistry, and this is the first image. You can see that the control means no treatment, it's showing albumin leakage in the cerebral cortex in mice model of Alzheimer's disease. But it was reduced when we had given cerebralizing. So this was the first proof that cerebralizing can reduce the blood-brain barrier in Alzheimer's model. Then to enhance nanodelivery of drugs, there are many ways. We are using titanium dioxide nanowires. This Dr. Purong Yan in University of California was the inventor of these titanium nanowires, but he did for electronics. This is titanium nanowire. What we are using is a US patent in Arkansas, and this is Dr. Ryan Tian and this is Dr. Ryan. They have the patent of this. It's called titanium dioxide nanowires. And there are many use of nanowires. You can make nanowires from silicon, copper, silver, and people have shown that even stem cells grown on nanowires, they live longer, their effectiveness is much better. So people are using nano delivery. And since we are working in Arkansas, nano wires are very expensive. So we have political support. At that time, this is the former governor of Democrat from Arkansas. He is helping our project because it requires millions of dollars to work on. We have submitted some innovation using titanium dioxide nanowire delivery of cerebralizing in various diseases to National Innovation Summit in the United States. Every year it occurs in summer. So we thought that are we doing right or wrong? So it is a multi-information. I mean, all military, FDA, and all government organizations are the expert members. We are surprised that when my wife submitted the innovation, it got top 15% technology award in that year. This is the certificate. Nanowire and alpha-melanocyte stimulating hormone and cerebralizing enhances cell protection in concussive head injury following sleep deprivation. This is very typical military problem. And also, the first time we submitted our innovation in 2013 to treat neuropathic pain. Neuropathic pain is very severe in military organization. If you amputation of hand, leg, whatsoever it is, then you have pain and also any damage of spinal cord injury. So it is untreatable so far. So we have used this nano delivery of cerebralizing for that purpose, and they found that this technology is top 20% in 2013. So we were impressed. And then they have lots of news around their own community. Then in 2017, my wife received another award for top 18% technology for cerebralizing in another technology. This is another traumatic brain injury induced Alzheimer's disease is thwarted by co-administration of nanowire, neprilysin and cerebralizing. This is top 18%. So I think we are doing right in that case, so I'm sharing some of the results with you. So amyloid beta peptide, the hallmark of Alzheimer's. You can see here that when we have given nanowire cerebralizing, this is much more reduced than the cerebralizing alone. This is anti. Then I showed you amyloid beta, we measured biochemically, and what we saw that nanowire cerebralizing reduced very similar to the control level. Tau, I discussed about that. So its level was also reduced when we have given nanowire cerebralizing as compared to cerebralizing. So the point is that when you deliver cerebralizing using nanotechnology, you have better, efficient neuroprotection. And this is our Alzheimer's disease model. We have infused amyloid beta peptide in such a dose for 4 weeks. And then we have studied light microscopy. This is Carl Davis, you can see. Amyloid deposit around the microvessels here after ABP infusion. And this is the leakage of albumin, untreated group. Nanowire cerebralizing did best in both these situations in reducing it. Cerebralizing also did, but nanowire cerebralizing is much better. Then we have studied astrocytic activation by GFAP control, and nanowire cerebralizing reduced the most. And likewise, neurons are much more better protected. This is mistless staining and 3 micrometer thick paraffin sections. And cerebralizing was also better, but nanowire cerebralizing is the best in our. Then we went to electron microscopy to study, because I am a neuropathologist and I believe that studying cell is very important rather than biochemical observations. Because studying cell at light and electron microscopy, you can decide that this is cerebral cortex layer 1, 2, 3, or even hippocampus, CA1, CA3, 4, which level. Because it is always happening that a drug can, if you have injury in one given region, all neurons are not dying. Some neurons are saved. And even one neuron is dying and the adjacent neuron is alive. This you can only detect by morpho. So then the question is that when you have given the drug, you can trace which neurons are alive and which are not. So that's why it is very important. So we went to electron microscopy. And you can see myelin. I'm also taking some myelin, as you have seen, Paulina. Yes. So this is ABP infusion. You can see how this myelin is damaged and the neuropil is completely damaged. Nanowire cerebralizing was able to reduce most of the myelination, but the damage is still there. But as you see this cerebralizing, it has protected. This picture is better than this one, but still so many evacuation edema is there. Now the again question that we asked, that no disease comes alone. If we have one disease, might be some other disease are also there. And that's why when you treat for one disease, clinical trials are not working quite well. So we try to understand that in not only normal animals, we deliver the same amount of infusion in disease animals, like head injury, diabetes and hypertension. I am showing some of the examples. So we repeat the experiments in animals that was produced diabetic using chemical streptozotocin. Okay? And now you see the albumin leakage, GFAP and even NIST neurons much more damaged when the same amount of was infused in diabetic rats as compared to the healthy animals. And titanium dioxide nanowire level is significantly reduced these changes. You can see these NIST neurons are much healthy here. GFAP is not so much and albumin is less. Then we are working on a large Alzheimer research group together with US, and it's a multi-million-dollar project. So we wanted to study how we can reduce some of the aspects. You cannot reduce all the aspects of Alzheimer. So this was the project. My wife gave a talk in last year, 9th clinical trials of Alzheimer's disease. This year it is 10th. We are going to Boston again. So then the question is that, can we further potentiate nano delivery of substance by adding some positive elements? So in this case, what did she did? Nanowire cerebralizing, she added anti-tau antibodies using nanowire delivery. And also we have written some editorials together that nanotechnology is the need of the hour. This is my colleague Dr. Rafin Morasan. He is a neurologist. At the moment he is working in Romania. So the background is there are so many evidences in not only Alzheimer, also traumatic brain injury, lipid peroxidation, oxidative stress. These are the enemy of the brain, and Alzheimer is not exceptional to this. And also elevated level of prostaglandins metabolites are also found. And the level of tau and these isoprostane correlates well in human cases. These are some of the literature where we have shown that people are treating monoclonal antibodies and tau-related matters. I summarize some of the literature from prostaglandin metabolite and tau in Alzheimer's disease. So what we did, we collected CSF from the sternum magna of these model, and brain tissue were obtained from cerebral cortex, hippocampus and cerebellum, and we measured biochemically. What you can see that amyloid beta infusion raised this isoprostane level in CSF, cerebral cortex, hippocampus and cerebellum. And in this case, we also tried another mode of delivery of cerebrolysine, PLGA, which is soft nanoparticles. And you can see that nano delivery was the best. It reduced the level in all brain areas and CSF. The same thing happened with phosphorylated tau. It has increased significantly as compared to the control. And when we have given another mode of nano delivery, we are seeing much reduced. But the point is here, I am showing this data, we also compared titanium dioxide delivery of cerebrolysine, and you can see this appears to be even better than PLGA level cerebrolysine. So the point is that the same drug can be delivered using various kinds of nanotechnology. We have to see that which nanotechnology is important for this drug in this particular condition. That is very important. So here are the example. You can see that this is the untreated group. You can see how neurons are bad. This is hematoxylin-induced staining. But when we have given this amyloid beta peptide together with tau antibodies and nanowire cerebrolysine, some cells were better protected. Here is you can't see any cell, either they are damaged or can't be seen. There is another example here. Nanowire cerebrolysine is doing better in protecting the cells. And this is the combination of antibody to tau and nanowire cerebrolysine. You decide yourself that here, more lively cells are here as compared to the untreated group, and this is only antibody. So the point is that you can potentiate delivery of cerebrolysine with other important elements that are working. But I must tell you here that by nano delivery, you can't make a bad drug to work good. The drug should be good, then it can be more effective. That's the message. Some other psychological problems, since we are working with US Air Force, it has military part included, and all world military, particularly women, are much more depressed than men. And that is one of the reasons that in many parts of the world, some of the military people take suicide because of depressive illness. It's not only related to the United States, it is prevailing in many countries. United States release the data, some countries don't release the data. That's the problem. This is taken from US Army and they have the data. I'll show you here. So the point is depressive illness related with suicidal thoughts. And if you are in military, the number of women committing suicide is higher. And this model is a depressive model in rat, where you put the forced swimming. We have shown that forced swimming alone increases blood-brain barrier. This is leakage of Evans loop. And here I can show you, in cerebral cortex, only few cells at certain level, maybe 1 and 2, and some in 3, they are damaged, but not all. And likewise in hippocampus, CF4 region, only few cells are damaged, but other cells are healthy. Then we did the same thing, nano delivery of cerebrolysine in this model. And you can see that untreated, then when we have combined this amyloid beta peptide in depressive animals, there is much more damage than the healthy animals. And I can tell you that nanowire cerebrolysine treatment is more effective than the PLGA level cerebrolysine. This is showing again the GFAP, and the results are very similar. Nanowire cerebrolysine was most effective in reducing activation of astrocytes as compared to PLGA. And these are the example of ABP deposit and albumin leakage. They are much better in nano delivery of cerebrolysine. And this is the case of spontaneous hypertension. These are some data I show you in emotional stress. And you can see that blood-brain barrier leakage to radioiodine and edema formation as water content. And these are neuronal injuries, different types, dark cells, swollen cell number, and distorted nerve cells, and activation of astrocytes. PLGA level cerebrolysin was much more effective in all counts. So the point is that either it is diabetic or depression, you exacerbate the pathology by giving the same amount of insult in case of amyloid beta peptide. What about headache? Head injury is much common in all military episodes. It can have closed head injury, means you have only bump, the skull is not broken, and that is much more dangerous than you have a open injury when the skull is fractured. This is our animal model of closed head injury. This is 114.6 gram is dropped out on the right skull over 20 centimeter. It gives an impact of 0.224 Newton in anesthetized animals, of course. And like counter coup mechanism, we see that the injured side is less damaged than the other side because there is a counter coup mechanism in the brain. So the uninjured left showing much more damage than the right side. The data is shown here just to make it short, that this is neuronal injury, amyloid beta peptide deposit, and albumin cells. Here is control, and amyloid beta peptide infusion plus traumatic injury has increased then from the control level, means healthy animals. And then you can see here that traumatic brain injury, amyloid beta peptide infusion, and nano delivery of mesenchymal stem cells and cerebrolysin was the best in reducing. Here is only mesenchymal stem cells, only cerebrolysin. So the combination of drugs with even stem cells are working better. I show you in this picture. Neuronal injury in parietal cortex, untreated means A beta infusion, nanowired mesenchymal stem cells, better, nanowired cerebrolysin, still better, but the combination is one of the best in saving neurons. What neprilysin can do? That's she got the award. Neprilysin is an enzyme. It is elevated in traumatic brain injury. It is also elevated in amyloid beta peptide. But people don't know whether it is for good or bad. In some cases, it is also reduced. So people are thinking that exogenous administration of neprilysin might help in reducing cell pathology. This is an example that neprilysin matches with amyloid beta peptide but not with GFA. Just to reduce the time, I am showing this table here. Look for this: nanowire cerebrolysin, nanowire neprilysin, and amyloid beta peptide infusion, and even traumatic brain injury. You can see that this column has all reduced values as compared to nanowire cerebrolysin plus amyloid beta peptide infusion alone. So the point is that combination of these two are working better. This is an example here that neprilysin and cerebrolysin, you can see that hippocampal cells are much more live than even after traumatic brain injury, of course, than cerebrolysin given alone. And this is the untreated. There are many dead cells, many space between the neurons. It means circulation, edema, and here is most lively cells. Then we are talking with some of the Nobel laureates. They have certain compounds with them, and they would like to see that how nano delivery of their compounds, either alone or together with cerebrolysin, can help reduce traumatic brain injury pathophysiological changes. So we believe that if we have identified few factors that are beneficial alone, their benefits can be enhanced by combining with other beneficial drugs, particularly when they are given using nano delivery. One of my friends in Italy, University of Modena, Dr. Giovanni Tosi, is expert in PLGA level delivery of many things. And so we leveled cerebrolysin, as I showed to you, and it is very stable for a longer period of time. It releases cerebrolysin, and now I just want to show you that this is the leakage of blood-brain barrier in different regions. And you can see here that titanium dioxide delivers cerebrolysin or PLGA delivers cerebrolysin. Both were significantly reduced from the untreated group, but it appears that the nanowire delivered cerebrolysin appears to have much